So let's talk now about distance and midpoint on the Cartesian plane. If we have a distance, so let's say we have 2 points, one here and one here, and we'll call this point A and this point B. So point A is well, usually when we say it, we just say A with brackets. Let's say it's minus 2 and 1 in height. Point B is going to be, let's say, 2 positive and 3 in height. If we want to find the distance between these 2 points, that length, so from here to here basically is going to be our distance, D is equal to the square root of x1 minus, x2 minus x1, x2 minus x1 squared plus y2 minus y1, whoops, I keep writing that opposite, sorry, y2 minus y1 squared. Oh my soul, what awful writing. Plus y2, did it again, y2 minus y1 squared. So let's work this out. x2 and x1, y2 and y1, we'll call this is point 1 and this is point 2. So D is going to be equal to the square root of x2, which is 2, it's the second point, 2 minus x1 is going to be negative 2, all squared, plus, brackets, y2, which is 3, minus y1, which is 1, all squared. I should say too, when I say this x2, x1, usually it's the larger point that's 2. By larger, I mean the one furthest to the top right in the first quadrant is going to be x2 and y2 and y1. The reason is because when you subtract these, they're going to be a positive number because we have 2 plus 2 because negative times negative is positive. So 2 plus 2 is 4 squared plus 3 minus 1 is 2 squared. If we had done it the opposite way and chosen this is point 2 and this is point 1, all that would have happened is these numbers would have come out as negative. So it would have been negative 4 minus 2. But remember that the negative is squared, right? So a negative squared becomes a positive, and it will work out either way. I like to choose the larger point as point 2, but whatever you choose should be fine. 2 minus minus 2 becomes 4 squared, plus 3 minus 1 is 2 squared. So 4 squared is going to be 16 plus 4, all square rooted. So this is going to be root 20. I'm just going to leave it as the root. You can type it under your calculator if you want to find out what it is. But that's the length between there. And that's how we use the distance rule. Let's go on to the second formula that's very, very handy when you're doing this in linear algebra, or if you're working in it's probably just questions you're doing just regular. So let's find the midpoint. A and B are here again. And I forget what I said. Let's say minus 2, 1, and 2, 3. So this is my A point and my B point. The midpoint formula says, where is the point in the direct center? If I had to pick the point in the direct center, where is that point? So we'll call this point C. Okay? The midpoint formula is x1 plus x2 over 2, y1 plus y2 over 2. That's right, okay. So we have x1 plus x2 over 2, comma, y1 plus y2 over 2. And this actually kind of makes sense because if we want to find point C, we say, okay, let's talk about just the verticals. We've got the average of the verticals would be the height of this point. So if this height is 1 and this height is 2, the average is 1.5 because 1 plus 2 is 3, 3 over 2 is just 1.5. So that's why this formula works out. Again, this is our first point, this is our second point. Let's just do this out. We're going to have x1 plus x2, so negative 2 plus 2 is 0, okay, over 2, comma, and this is just the y coordinate, y1 and y2 is going to be 4 over 2, which is equal to 2. So the point is 0, comma 2. That is our point C. So let me erase this C off here, and let's actually plot these, how they're going to go. So we've got negative 2, right there, and plus 1, and we've got positive 2 and plus 3, so 1, 2, 3. So I've drawn it a little bit skewed, but that's how it goes. So our new point we found is 0, 2, and look at that. it shows up almost exactly in the center of the way I've drawn it, like that. So that would be the midpoint of this. So we talked about the midpoint formula and the distance formula. If you have any questions, again, leave them in the comments.